A single bolt, tightened by hand, can decide whether a $200,000 custom motorcycle survives its first summer on the highway or falls apart at 70 miles an hour. That is not an exaggeration. That is the reality inside one of the last major motorcycle factories on Earth that still refuses to let machines finish the job alone. Millions of people ride Harley-Davidson motorcycles. Almost none of them know what actually happens on the other side of that factory wall. They assume it is robots. They assume it is a modern assembly line, cold, automated, indistinguishable from a car plant in Detroit or a smartphone plant in Shenzhen. That assumption is wrong, and the truth is stranger, slower, and far more human than anyone expects, because somewhere in the American Midwest, in buildings that have stood for generations, real people are still torquing engine bolts with their own hands, listening for the sound an engine makes before it has even started, and signing their name to machines that will outlive some of the people who bought them. This is the story of how a Harley-Davidson motorcycle is actually built, piece by piece, station by station, hand by hand. And by the end, you will understand why this company has survived wars, recessions, bankruptcy threats, and 100 competitors who build faster and cheaper, without ever fully giving up the one thing that made it famous in the first place. Let's go inside. Most people picture a motorcycle factory the way movies show it. Sparks flying, robotic arms spinning in perfect synchronization. Nobody inside except a technician glancing at a screen. That image comes from car manufacturing, and it has quietly become the assumption for everything else too, including motorcycles. The real story is more complicated. Harley-Davidson does use automation, and it uses a lot of it, especially for the heavy, repetitive, dangerous work that machines are genuinely better at. But the deeper you go into the process, the more human hands you find, not fewer. That is the twist almost nobody expects out to understand why. You have to go back before the factory even existed. In 1903, in a wooden shed in Milwaukee, Wisconsin, 21-year-old William Harley and his childhood friend Arthur Davidson built a motorized bicycle by hand because that was the only option available. There were no assembly lines. There was no automation. Every part was shaped, fitted, and adjusted by a person with tools and patience. That shed produced exactly one motorcycle that first year. What matters is not the shed itself. What matters is that the company built around it never fully abandoned that origin story, even as it grew into a global brand producing hundreds of thousands of motorcycles a year. That tension, between industrial scale and handcrafted identity, is the engine underneath everything you are about to see. By the 1920s, Harley-Davidson had already become the largest motorcycle manufacturer in the world, supplying machines to the United States military during the First World War and building a genuine assembly process for the first time, moving away from the one-at-a-time construction of the founding years. Even then, though, the company's growth looked nothing like the automotive assembly lines Henry Ford was perfecting just a few hundred miles away in Detroit at almost exactly the same time. Cars were being simplified for mass production, with interchangeable parts and minimal customization, built for speed of output above almost everything else. Motorcycles, by contrast, remain mechanically complex enough and low volume enough. That skilled labor stayed central to the process for decades longer than it did in the car industry. That gap never fully closed. Through the Great Depression, through a Second World War that saw the company producing tens of thousands of military motorcycles, and through the post-war boom that turned Harley-Davidson into a cultural symbol of American independence, the manufacturing process kept evolving in complexity and scale, but never abandoned its reliance on trained human hands at the most critical stages. That is the inheritance every modern factory worker steps into the moment they clock in for their first shift. But that's only part of the story. Because building a motorcycle by hand at low volume in 1903 is one thing. Building tens of thousands of motorcycles a year while still preserving a hand-built feel in the 21st century, against competitors from Japan and Europe who mastered lean automated manufacturing decades ago, is an entirely different challenge. And the way Harley-Davidson solved that challenge reveals something important about how the company actually thinks. The modern process begins long before any metal is cut. It begins with a frame, and the frame is where the personality of every Harley starts to take shape. And like many manufacturers who stamp out frames as thin, hollow, disposable structures, Harley frames are built to carry enormous stress for decades, sometimes passing between 3 or 4 owners across 40 or 50 years of riding. Steel tubing arrives at the plant already cut to length from suppliers, but the actual frame construction happens on site, where robotic welding arms handle the initial structural welds. This is one of the places automation genuinely shines. A robot can place a weld in exactly the same spot, at exactly the same temperature, thousands of times in a row, without fatigue, without a shaky hand, without a bad day. For structural integrity, that consistency is not a luxury. It is a safety requirement. Here is the part almost nobody expects, though. After the robots finish the primary welds, human inspectors and finishing welders go over every single frame by hand. They check weld quality with trained eyes that can catch inconsistencies a camera sensor might miss. They smooth transition points. They verify that the geometry, the exact angles that determine how the bike will handle at highway speed or lean into a curve, has not shifted by even a fraction of a degree during the welding heat cycle. Why does that matter so much? Because frame geometry on a motorcycle is not like frame geometry on a car. A car has 4 contact points with the ground and a wide, stable base. A motorcycle has 2 contact points and a rider whose body weight actively changes the balance of the entire machine in every turn. A frame that is off by a small amount will not just feel wrong. It can make a bike genuinely unstable at speed. That is why, even in an era of laser-guided robotic welding, Harley-Davidson keeps trained human eyes as the final checkpoint on every frame that leaves that stage of production. What happened next completely changed the direction of motorcycle manufacturing across the entire industry. And it started with the engine. The engine is the emotional core of a Harley-Davidson. More than on almost any other consumer vehicle in the world, riders can often identify a Harley by sound alone, from the distinctive potato-potato rhythm of the V-twin exhaust note. That sound is not an accident. It comes directly from the 45-degree angle between the 2 cylinders, a design choice William Harley made over a century ago that created an uneven firing interval unlike anything else on the road. Harley-Davidson even pursued a trademark on that exact sound in the 1990s, which tells you how central it is to the brand's identity. Even though the trademark application was eventually withdrawn after years of legal challenges from competitors, building the modern Milwaukee 8 engine, the current large displacement V-twin used across most of the touring and cruiser lineup, starts with precision casting of the engine block, cylinders, and heads. These raw castings go through extensive CNC machining, computer-controlled cutting that shapes the metal to tolerances measured in microns, far tighter than any human hand could achieve consistently. This is another area where machines are simply the better tool for the job. And Harley-Davidson does not pretend otherwise, but once the machine components are ready, the actual engine assembly becomes something closer to watchmaking than mass production. Technicians install pistons, connecting rods, camshafts, and valve trains by hand, working at individual stations rather than a fast-moving conveyor. Every major bolt on that engine, from the head bolts to the crankcase fasteners, gets torqued using calibrated hand tools set to exact specifications, often applied in a specific sequence and pattern to ensure even pressure across a gasket surface. This sequencing matters more than most riders realize. Tighten head bolts in the wrong order, even with the correct final torque, and you can warp a cylinder head just slightly enough to cause an oil leak or a compression loss that will not show up until thousands of miles later. A machine could theoretically be programmed to follow that same sequence, but Harley-Davidson has found that skilled technicians, many with a decade or more of experience on that exact engine platform, catch subtle problems, a slightly rough thread, an inconsistency in a gasket, a fastener that spins just a little too easily, that automated torque wrenches alone would miss. The technology and the human judgment work together, not one instead of the other. Not every engine on the line is identical, either, and that adds a layer of complexity most viewers never consider. Harley-Davidson currently produces the Milwaukee 8 in several displacement variants, commonly referred to by cubic inch size, each tuned for a different riding experience and a different customer. A touring rider crossing several states in a single day wants smooth, reliable torque at low engine speed. A performance-focused rider wants sharper throttle response and a more aggressive power curve. Building that range of personalities from what is fundamentally the same engine architecture requires component swaps. different camshaft profiles, different compression ratios, and different tuning maps loaded into the onboard computer, all of which have to be tracked with total accuracy so the right parts end up in the right engine. At the very top of that range sits the Custom Vehicle Operations Program, often shortened to CVO, Harley-Davidson's in-house equivalent of a low-volume, high-performance division. CVO models receive the largest engine displacements the platform offers, along with extensive hand-applied paint graphics, premium hand-stitched leather seating, and additional finishing work that can add many extra hours of skilled labor to a single unit compared to a standard production model. These bikes are effectively a demonstration of what the factory's hand-built philosophy looks like when cost is not the primary constraint. And the price tag reflects exactly that. This leads us to the next major reason Harley-Davidson has resisted full automation on final engine assembly, and it comes down to variety. And like a car company producing one engine variant by the hundreds of thousands, Harley-Davidson builds multiple engine displacements, multiple trim variations, and custom configurations for touring bikes, cruisers, and performance models, sometimes on the very same day, on the very same line. Reprogramming robotic assembly for that level of variation, switching specifications constantly throughout a shift, is far more complex and expensive than training human technicians who can adapt instantly by simply reading the build sheet in front of them. However, the real surprise came later, once the engine and frame come together on what the plant calls the marriage station. This is where the completed engine, already built and tested as its own unit, is lifted and lowered into the frame by an overhead hoist system, then bolted into place by technicians working in coordinated pairs. It is called a marriage for a reason. From this point forward, that specific engine and that specific frame are permanently linked by a matching set of identification numbers, tracked through the entire rest of production and into the machine's service history for the rest of its life. If a Harley-Davidson dealership technician looks up a bike's records 20 years from now, that engine-to-frame pairing traces directly back to this exact moment on the factory floor. After the marriage comes the electrical harness, one of the most underestimated parts of modern motorcycle assembly. A contemporary Harley-Davidson is not just an engine and two wheels anymore. It carries onboard computers managing fuel injection, ignition timing, anti-lock braking, traction control on higher trims, infotainment systems, heated grips, and increasingly, ride modes that let a rider electronically adjust throttle response and suspension behavior, routing that wiring harness through a frame packed with moving mechanical parts, without a single pinch point or chafe risk that could cause a short circuit years down the road, is detailed, painstaking work. This is almost entirely done by hand, because the wiring routes differ across model variants. Touring bikes need harnesses for entertainment systems and heated seats that a stripped-down cruiser does not. And because a misrouted harness is exactly the kind of subtle mistake that a rushed automated process might not catch until a warranty claim comes in 2 years later, that's where things became even more interesting. Because next comes something almost no other vehicle manufacturer on Earth still does at this scale. Paint. Harley-Davidson's paint process is closer to automotive customization shop work than typical factory painting. Base coats are applied in controlled environments with some automated spraying for even coverage and environmental consistency. But many models, especially anything with two-tone paint schemes, pinstriping, or the brand's iconic flame and graphic packages, require hand-tape masking and hand-applied detail work from painters trained specifically in that craft. A pinstripe running the length of a fuel tank, for example, needs a steady human hand guiding a brush or a specialized tool at a consistent speed and pressure, because a robotic arm following a programmed path cannot replicate the tiny natural variations that make a hand-painted line look organic rather than printed. Ironically, that imperfection is exactly what customers are paying for. It is proof that a person, not a machine, touched their motorcycle. After paint, tanks and fenders go through multiple clear coat layers and curing cycles in temperature-controlled ovens, sometimes taking longer than the assembly of an entire lower half of the motorcycle. Quality inspectors check for orange peel texture, dust inclusion, and color matching under specific lighting conditions designed to reveal flaws invisible under normal factory lights. A tank that fails inspection does not move forward. It gets pulled, sanded back, and repainted from scratch, even if that means delaying that specific unit's place on the line. Color matching itself is a hybrid process worth pausing on. Computerized spectrophotometers scan a sample panel and compare it against a digital reference file for that exact paint code, catching deviations invisible to the naked eye. But final approval still comes from a trained human eye under standardized lighting, because color perception on a curved metal surface, under sunlight, and a customer's driveway behaves differently than color read by a sensor in a lab. A shade that measures as technically correct on a sensor can still look slightly wrong to a trained human eye. And Harley-Davidson's inspectors are specifically trained to catch that gap between the numbers on a screen and the real world impression a rider will actually see standing in front of the finished bike. Some limited run and anniversary editions go even further, incorporating multi-layer candy paints, hand-laid metal flake, or graphic transitions that blend to colors along a hand-guided line rather than a hard masked edge. These techniques can add hours to a single fuel tank's finishing time, and they exist for one reason only, because a machine-perfect gradient looks noticeably different from one a human painter blends by feel. And buyers of these higher-end editions are specifically paying for the version only a person can create. Meanwhile, the wheel and tire assembly happens on a parallel line, where wheels are balanced using both computerized measurement and manual fine adjustment. Because an imbalanced motorcycle wheel does not just cause a rough ride, it creates a wobble that intensifies dangerously at highway speed, a phenomenon riders sometimes call a speed wobble or tank slapper. Getting that balance precisely right is treated as a non-negotiable safety step, not a convenience feature. Now here is where all of these separate paths, frame, engine, electrical, paint, wheels, finally converge on what workers simply call final assembly. This is the stage most people picture when they imagine a factory, a moving line where the motorcycle takes its final shape. But even here, the pace is dramatically slower than most industrial assembly lines, where a car might move through a station every minute or less. A motorcycle at certain critical stations can spend considerably longer, because so many of the remaining tasks require torque verification, fitment checks, and alignment work that simply cannot be rushed without risking a functional or safety failure. Handlebars are installed and aligned to precise specifications relative to the front wheel. Brake and clutch lines are connected and bled by hand to remove air bubbles that could cause spongy and reliable braking. Seats, fuel tanks, exhaust systems, and bodywork panels are fitted with careful attention to gap consistency, the same visual standard luxury car buyers expect. Because uneven panel gaps on a motorcycle are immediately obvious to a customer standing in a showroom, technicians at this stage often specialize in specific subsystems. One team focused entirely on brake and suspension setup, another on electrical connections and diagnostics, another on final trim and badging. This specialization means workers develop deep expertise in their specific station, sometimes performing the same category of task for years, building the kind of pattern recognition that lets an experienced technician notice a problem within seconds that a newer employee might miss entirely. Training for these specialized roles is not a quick process either. New technicians typically spend months shadowing experienced workers before they are trusted to independently complete critical torque or inspection tasks on their own. And some of the most senior employees on the floor have spent 20, 30, even 40 years working the same general area of the plant, accumulating a depth of tacit knowledge about how a specific engine platform behaves that simply cannot be written into a training manual or transferred into a line of code. When a veteran technician says a particular bolt feels wrong before any gauge confirms it, that instinct is the product of decades of repetition. And Harley-Davidson has structured its production process specifically to make room for that kind of expertise to matter. This leads us to one of the most important and least publicized parts of the entire process: individual bike testing. Before a completed motorcycle is cleared to leave the factory, it does not simply get a visual inspection. Many models go through actual running tests, engines started and run through their paces, checked for oil pressure, listened to for unusual noises, verified for correct idle and throttle response. Some undergo dynamometer testing, essentially a treadmill for motorcycles, that measures horsepower output and confirms it matches expected specifications for that engine and trim. Others are physically test-ridden on a closed track adjacent to the factory, where a trained rider evaluates handling, braking feel, and overall ride quality before signing off. Think about what that actually means. A machine costing anywhere from $10,000 to well over $40,000, depending on trim and customization, gets a literal human test ride before it is packaged and shipped. That is a level of individual scrutiny most manufactured products, in almost any industry, simply do not receive. A smartphone does not get personally test-operated before shipping. A washing machine does not get run through a full cycle by an inspector before it leaves the factory. But a Harley-Davidson motorcycle, in many cases, does get ridden. Beyond the individual test ride, there is another layer of scrutiny most customers never hear about. On a rotating basis, completed motorcycles are pulled at random directly off the end of the line before they are ever crated, and sent to a separate quality audit area for a full tear-down inspection. Inspectors there disassemble sections of the bike that a normal quality check would never touch. Checking torque values with a calibrated tool, verifying internal fluid levels, and inspecting components that are completely invisible once the motorcycle is fully assembled. This is not done because a specific unit is suspected of a problem. It is done precisely because it is not suspected of anything. A random statistical check designed to catch a systemic issue at its earliest possible point, before it ever reaches a dealership floor or a customer's driveway. Once a motorcycle clears every checkpoint, it still is not simply rolled onto a truck. Final units go through a detailed pre-shipping inspection covering fluid levels, tire pressure, battery charge, and a full walk-around for cosmetic defects that might have occurred anywhere earlier in the process. Only then are they carefully secured, often by hand, into shipping crates or onto transport racks designed specifically to prevent even minor vibration damage during transit to dealerships across the country and, for exported models, across oceans. Even after all of that, most dealerships perform their own pre-delivery inspection once the bike arrives, meaning a single Harley-Davidson motorcycle can pass through several rounds of dedicated human inspection before a customer ever swings a leg over the seat for the first time. Of course, this comes with real trade-offs, and to stay balanced, those trade-offs deserve honest attention. This level of manual craftsmanship is expensive. Labor costs at Harley-Davidson's American manufacturing facilities are significantly higher than at competitor plants that rely more heavily on automation, or that operate in lower labor cost countries. That expense shows up directly in the price tag riders pay, and it is a major reason why a Harley-Davidson touring bike can cost noticeably more than a comparably sized motorcycle from a Japanese manufacturer with a more automated, higher volume production model. Production speed is also slower, where some competitor factories can produce a comparable motorcycle in a fraction of the labor hours. Harley-Davidson's hybrid approach, heavy automation for structural and repetitive tasks, combined with extensive hand finishing and human testing, simply takes longer per unit. During periods of high demand, that has occasionally created longer wait times for certain popular models and trims, frustrating customers eager to get their bike sooner. There is also the question of consistency versus character. A fully automated process theoretically produces more uniform results unit to unit, with zero variation from one bike to the next. Harley-Davidson's hand-finished approach, while producing motorcycles that meet strict engineering tolerances, does allow for the kind of tiny natural variation in paint application, in fit and finish details, that some critics see as inconsistency and that other buyers see as authenticity. Neither view is wrong. It depends entirely on what a rider values. But here's why all of this actually matters beyond just curiosity about a factory floor. The choice to keep human hands central to the process is not nostalgia for its own sake. It's a business strategy tied directly to what customers are actually buying. People who purchase a Harley-Davidson are rarely buying pure transportation efficiency. Cheaper, faster, more fuel-efficient options exist in nearly every category the company competes in. What Harley-Davidson customers are buying is heritage, identity, and the specific emotional experience of owning something with a story behind it. A machine that connects them to over a century of American manufacturing history and to the actual people who assembled their specific unit. That emotional connection explains something else you will notice if you ever visit certain Harley-Davidson facilities in person. Many long-serving employees take genuine pride in their specific station. some even signing or initialing components they personally built or inspected, a practice that echoes the earliest days of the company, when a small team in Milwaukee knew every single motorcycle they produced by name. It also explains why the company has survived multiple near-collapse moments across its history, including a period in the 1980s when a management buyout saved it from a struggling parent company, and a 2008 financial crisis that hit motorcycle sales industry-wide. Through all of it, Harley-Davidson leaned harder into its identity rather than away from it, betting that customers would pay a premium for authenticity rather than simply chasing the lowest price or the fastest production line. That bet has not always paid off perfectly. The company has faced real challenges attracting younger riders, has gone through painful factory closures and consolidations over the past decade, including the closure of its longtime Kansas City plant, and continues to navigate a motorcycle market where overall ridership demographics in the United States have shifted significantly since the 1990s. Its manufacturing philosophy is not a magic solution to every business problem the company faces, but it does explain something deeper about why this particular brand still commands the loyalty it does, decades after competitors began outproducing it in both volume and price. When a rider sits on a Harley-Davidson motorcycle, they are not just sitting on an engineered machine. They are sitting on the end result of dozens of individual human decisions. A torque applied by a specific set of hands, a pinstripe guided by a trained eye, a test ride completed by a real person who listened to that exact engine before anyone else ever would. That philosophy is now being tested in a way it never has been before. With the rise of electric motorcycles, Harley-Davidson's Livewire brand, its electric motorcycle division, strips away the exact component that defined the company's identity for over a century: the internal combustion V-twin engine with its distinctive rhythm and sound. Building an electric motorcycle involves battery pack assembly, electric motor integration, and software calibration, work that leans far more heavily toward precision electronics and far less toward the kind of hand-torqued mechanical assembly that defines a traditional Harley engine build. That shift raises a genuinely open question for the company's future. If the emotional connection so many riders feel comes partly from knowing a real person built their engine by hand, what happens to that connection when the engine disappears entirely, replaced by a battery and a motor built primarily through automated processes common across the broader electric vehicle industry? Harley-Davidson has not fully answered that question yet, and arguably, the market has not either, since electric motorcycle adoption still represents a small fraction of the company's overall sales. But it is a real fault line running underneath everything this factory represents. 120 years of hand-built identity meeting an electric future that may not need hands in the same way at all. That is a manufacturing philosophy most of the industrial world abandoned decades ago in the name of speed and cost efficiency. Harley-Davidson never fully did, and whether you see that as an efficient stubbornness or as one of the last true craftsmanship traditions left in large-scale American manufacturing, it is impossible to deny that it has shaped not just how